Okay, so we're going to first, I'm going to introduce you to each of the pieces of equipment that you're going to be using. The first one you're already familiar with, is a computer. So we have a computer at every workstation, and what you're going to do is to log into that computer so you can access the files you need and record your data and so forth if you want to do it that way. Now, you're perfectly welcome to bring your own laptop or your any other kind of device if that's more convenient for you. But you do have access to your engineering network H drive from these computers. For my purposes today, what I'm doing is I've actually printed out the lab, and you'll notice on here that the lab number is not lab 1. It will be for you, but I'm pulling this up and repurposing an older lab from last year. So don't worry about that. Things will be a little bit different on your sheet. All right, so what we're going to do is to get familiar with each one of these instruments. You'll see the picture of the oscilloscope. Well, that's this animal right here. The oscilloscope is used for measuring and displaying voltage. So there are 2 channels on this oscilloscope. Some have more than that, but this oscilloscope has 2 channels. You can see there are 2 connectors, and they're color-coded. There's yellow and blue. And so when we turn this on and get ready to use it, it'll be kind of like turning on a computer in the sense that you'll see a boot up screen, and that's what we're looking for there. So it's software driven, but it is actually interacting with real world hardware. So we'll learn the function of some of these buttons as we go through the lab experience. The other piece of equipment that's addressed here is the power supply, and this is just sort of a fancy battery, if you want to think of it that way. What it does is it produces voltage, and you can adjust the voltage to whatever your needs are. This one comes up and it's already set to 5 volts, but I can change that to any voltage that I want. In fact, I can change it very precisely. I can change tenths of volts and even hundredths of volts. So if I want to do an experiment that requires me to very carefully measure voltage changes, I can do that. Now over here, this is reading out current, and you can see it's showing 0 because there's nothing connected, so no current can flow yet until I connect something here. But that's our power supply, and then we have this animal called a function generator. I'm not doing this quite in the same order it's in the write-up, but the function generator produces signals. It produces voltages that have a certain pattern. So what you can see here is the pattern, the wave shape, can be a sine wave or a square wave or a pulse or a triangle wave or sawtooth are the names for those. And you can change the frequency range, and then you can use this knob to adjust the actual frequency. So when we turn this on, the display shows the frequency of the waveform that's being generated. So we'll learn how to use that as well. And so when we connect the function generator to the oscilloscope, which it's not right now, but when we do that, you'll see what those wave shapes look like. There's one more piece of equipment, and I'm gonna walk around, show you what the lab looks like. This whole area over here is gonna be cleaned up when you come in. We're just, right now, I'm still resetting from our summer experiences in here. But this piece of equipment that I just picked up and carried over here is a portable digital multimeter. It's probably one of the most standard pieces of equipment. In fact, if you've used any electronic equipment, no doubt you've probably used something like this before. So there are a lot of functions on here, and we only use a few of them in this lab actually. The ones that we use the most are reading the voltage and reading resistance. And so when we turn this on, whatever it reads depends on what range it's set at. So right now, it's set over here to read continuity. So that little musical note tells you it's set up so that if I short the terminals, it'll tell you that it's shorted. Okay. Now, there's another way to read the same thing, which is to turn it to resistance, any resistance range. That one with a dot, sorry about the lighting, that one with a dot just means that it's reading, whatever the reading is, it's over the range it's able to read. So infinite resistance, so it can't actually display infinity, but there's no connection. But now if I connect these probes together, you can see it goes to 0. Forget the minus sign, that's just a, you know, there's a limited precision at the low end, so that minus sign doesn't mean anything. It's telling you that there's 0 resistance now between the leads. Okay, so that's the digital multimeter short version, but we'll look at it more in just a minute. I'm going to go ahead and end this video segment and then start the other one.